I want you to start off today by doing something really simple for me. Just hold up your hands and look at them.
Always a good place to start.
Right. Just look at the skin, the lines on your palms. Maybe like press your thumb against your fingertips or tap them on the desk in front of you.
Mm-hmm.
Feel how solid that is. Because in our everyday experience, matter is this totally undeniable, tangible thing. It has weight, it takes up physical space, it pushes back when you push it.
Yeah, we're deeply wired to experience the world that way.
Exactly. We are taught from a very young age that matter and energy are two completely different categories of existence. You have the hard stuff, the atoms, the protons, the electrons, and then you have the energetic stuff,
Like light.
like light, just zipping through the empty space between the hard stuff. But what if that dividing line doesn't actually exist?
Which is a huge question.
It is. What if every single subatomic particle making up your hands, the chair you're sitting on, the device you are using to listen to us right now, what if all of that is actually constructed entirely out of trapped, swirling light?
Yeah, blurring that line, it fundamentally rewrites how we picture reality at the most basic level. I mean, we are so accustomed to thinking of subatomic particles as like tiny billiard balls.
Right, little solid spheres.
Exactly. But if you take a step back and look at quantum field theory, the whole billiard ball concept really starts to dissolve.
It falls apart.
It does. The idea that solid matter is just, an illusion created by confined electromagnetic energy, it forces us to abandon basically everything we think we know about mass, charge, and even the very geometry of space itself.
Okay, let's unpack this, because today we are taking a massive plunge into the world of subquantum mechanics.
A very deep dive.
A true deep dive. We are exploring a radical alternative to the standard model of physics. It's a theoretical framework that attempts to explain the entire universe using just three ingredients, which are space, time, and confined energy. Nothing else.
Which sounds simple, but the implications are staggering.
Totally staggering. And to do this, we are drawing from a very specific stack of materials today. We're looking at some really fascinating video presentations from the Huygens Optics channel.
They do a phenomenal job of visualizing complex topological physics, by the way.
They really do. The visuals are crucial for this. We also have promotional and philosophical literature from a group called the Quizzical Society, along with their official website. But the real anchor for our deep dive today is a dense, peer-reviewed 2015 physics paper.
Right, titled On the Nature of the Photon and the Electron by Dr. J.G. Williamson.
Yes. So our mission today is to completely deconstruct the mainstream idea of the point-like particle. We want to explore whether the fundamental building blocks of our universe are actually tiny, impossibly fast bicycles made of light.
Bicycles made of light. It's such a wild image. So the Quizzical Society, which is short for the Quantum Bicycle Society,
Oh, that makes sense.
right? It was founded by Dr. John G. Williamson, who is a physicist formerly with CERN in Glasgow University, and Dr. Martin B. Vandermark from Phillips Research Labs.
Okay, so these are serious guys.
Very serious. And their core thesis proposes that stable subatomic particles, specifically the electron, are not fundamental indivisible dots.
Which is what we're usually taught.
Exactly. Instead, they propose that an electron is composed of an internal photon. So a localized wave of electromagnetic energy that is making two complete revolutions per wavelength.
Wait, two revolutions?
Yeah, it is quite literally light that has managed to tie itself into a self-sustaining knot.
Okay, before we jump into the actual mechanics of tying light into knots, which we will definitely get to, we need to understand the structural flaw in mainstream physics that drove these scientists to reinvent the electron in the first place.
The underlying problem.
Right, like why do we even need a new model?
Yeah.
And it really all stems from 1897 when J.J. Thomson discovered the electron, because since that discovery, mainstream physics has treated the electron as a point-like entity.
Yes, a zero-dimensional point.
Which means it has no dimensions, like none. It has no length, no width, no depth, no internal structure whatsoever. It is literally treated as a pure mathematical coordinate where properties like mass and charge just sort of reside.
Sit there, yeah.
Mhm.
But treating a physical object possessing mass and charge as a zero-dimensional point, it creates an immediate catastrophic mathematical paradox.
I love a good paradox.
Well, this one is a headache. It's regarding the energy of its electric field. Let's trace the math on that. Think about a classical electric charge.
Okay.
The energy of the electric field radiating outward from that charge is inversely proportional to the radius.
Right.
So the smaller the sphere that contains the charge, the more intensely compressed that field energy becomes near the center.
Right, you're packing the same amount of stuff into a tighter space.
Exactly. And if you try to calculate the total energy of that field, you have to integrate from the radius of the particle all the way out to infinity.
And here's where the math breaks. Because if you set the radius of the particle to exactly 0, you are physically dividing by 0 in your integration.
Which you can't do.
You can't. The mathematical result just blows up. The field of that zero-dimensional point charge would have to contain an infinite amount of energy.
But we know for an absolute fact that an electron does not contain infinite energy.
Right.
If you use Einstein's E = mc squared, you can actually measure the mass of an electron at rest and calculate its total energy equivalent.
And it's a very specific number.
It is. That finite energy is roughly 0.511 mega-electron volts.
So treating an electron as a zero-dimensional point is kind of like trying to pack the mass of the sun into a geometric pinpoint. The math just completely breaks.
That's a great way to put it.
So my question is, how does the Standard Model, which is, arguably the most successful predictive theory in the history of science, how does it function day to day when its foundational particle generates a literal infinity sitting right in the middle of the equations?
Yeah, it is the million-dollar question. Mainstream physics handles this through a mathematical procedure called renormalization.
Renormalization, okay.
Right. When quantum electrodynamics equations yield these infinities, physicists essentially calculate the difference between two infinite quantities to leave behind a finite measurable number.
Wait, they subtract infinity from infinity?
Basically, yes. To get a number that matches our experimental data, it's a highly complex, very pragmatic workaround. And to be fair, it allows us to build particle colliders, lasers, quantum computers.
Because the math works out in the end.
Exactly.
Mm-hmm.
The predictive outputs match reality beautifully. However, Dr. Williamson and Dr. Vandermark argue that renormalization, well, mathematically useful, it ignores the physical reality of the object.
You're just hiding the problem.
Right. You are discarding the infinity without resolving the actual geometric impossibility that caused it in the first place.
If the math tells you the energy is infinite, and the actual physical universe tells you the energy is 0.511 mega-electron volts, simply subtracting the infinity away to get the answer you want feels like treating the symptom while totally ignoring the disease.
That's exactly their argument. If you take that known finite energy of 0.511 mega-electron volts and you work the classical equations backward.
Like reverse engineering it.
Yes. Asking the math, how large must a sphere be to contain exactly this much energy and no more? You get what is called the classical electron radius.
And what's that number?
That value is roughly 2.8 times 10 to the negative 15th meters.
Okay, so that is incredibly small.
Very small.
Yeah.
But the crucial takeaway is that it is distinctly not zero.
It has a size.
It has to. And beyond the energy paradox, there is also a severe spatial paradox with the point particle model. We know electrons possess spatial asymmetry.
Meaning they aren't just perfectly uniform dots?
Exactly. They have a magnetic dipole moment, which means they function like microscopic bar magnets with a distinct magnetic north and a distinct magnetic south pole.
Which is weird if they have no dimensions.
Very weird. They also possess an intrinsic angular momentum, which physicists call spin.
Okay, wait. Let's look at the geometry of that for a second. How can a particle with absolutely no dimensions possess a north and south pole? You cannot have poles if you do not have physical extension in space.
You need a top and a bottom.
Right. If you have no top or bottom, no left or right, a dipole moment is conceptually impossible. And how can something with zero radius physically spin? Angular momentum requires a mass or energy distribution rotating around a central axis.
Exactly.
If the distance from the axis is 0, the angular momentum should just be 0.
That is the exact logical wall the quizzical researchers hit. The physical properties of the electron absolutely demand extension in space. You simply cannot fit a magnetic dipole or angular momentum inside a zero-dimensional coordinate.
It's like trying to fit a real physical object into a theoretical idea.
Right. The point particle framework fails to map onto the physical reality of what the electron actually does.
Which leads us directly into their proposed solution. Because if the foundation is cracked and the electron is definitively not a point, what is its actual physical structure?
What is it really?
Yeah. This brings us to their 1997 paper, which asks a very specific question. Is the electron a photon with toroidal topology?
Toroidal topology.
Which is just a mathematical way of describing a donut shape. So they are visualizing the electron not as a solid chunk of fundamental matter, but as a single Compton wavelength of circularly polarized electromagnetic field bent into a donut. Let's break down the mechanics of that specific shape.
Yeah, let's start with just a freely traveling photon. Electromagnetic radiation consists of an electric field and a magnetic field oscillating perpendicularly to each other as they move through space.
Like waves on an ocean.
Sort of, but in a circularly polarized photon, those fields aren't just waving up and down, they are rotating around the axis of travel, like corkscrewing through space.
Oh, okay. I can picture that.
The length of one complete corkscrew rotation is the wavelength. The model proposes taking a single wavelength of this corkscrewing energy, specifically the Compton wavelength, which corresponds exactly to the 0.511 mega electron volt energy of the electron,
And then bending it.
and bending it.
The sources from Huygens optics provide a really vital visualization for this, I think. Imagine you are holding a flat, rectangular strip of paper.
Oh,
This strip represents that single Compton wavelength of the photon. On this strip, the magnetic field is oriented flat against the plane of the paper, running longitudinally down the length of it. And the electric field is perpendicular, pointing straight up from the surface of the paper.
so we have our flat wave.
Right. Now, give that strip of paper a half twist and bend the two ends around to connect them. You have just created a Mobius strip.
Right, the classic shape with only one surface.
Exactly. But the Quizzical model goes a step further than that. It requires a full, continuous double loop.
Yes. The geometry they propose forms a toroid, where the energy traces a path that rotates over a full 2 pi radians along the outer surface of the donut, while simultaneously rotating over 4 pi radians around the minor cross-section of the donut.
Wow.
It is a double helix loop, closed in on itself.
Here's where it gets really interesting to me. By bending this strip of light into a closed double loop, something massive happens to the momentum.
Right.
Because a normal photon has linear momentum. It travels forward in a straight line at the speed of light, see? But in this toroidal shape, the linear momentum is completely converted into angular momentum.
It stops moving forward.
The light is permanently trapped. It's continuously racing around this donut track at the speed of light. The momentum is suddenly confined to a localized region of space.
And this confinement is the absolute key to understanding mass.
Tell me more about that.
Well, in standard physics, mass and energy are treated as equivalent but distinct states, right?
Right,
E equals mc squared.
right.
But in this model, mass is nothing more than the inertia of confined energy.
Wait, mass is just trapped momentum.
Yes. Because the field energy is permanently trapped within this specific volume, oscillating internally but never actually translating forward through space, it resists being accelerated or decelerated by outside forces.
It pushes back.
To the outside macroscopic world, that resistance to acceleration manifests exactly as inertial mass. The physical stuff of the electron isn't some new material substance. It is exclusively the trapped momentum of the light.
That is just mind-bending, but I'm stuck on the physical mechanism of the bend.
Okay.
Light naturally travels in a straight line in a vacuum. We know extreme gravity can bend light, like gravitational lensing around a massive galaxy.
Ugh.
But an individual electron doesn't possess anywhere near enough mass energy to generate a gravitational field capable of trapping its own light into a microscopic donut. So if gravity isn't pulling the light into this loop, what is forcing the trajectory?
The model relies on the mathematical concept of geodesics to explain the trajectory, completely independent of gravity. Right. A geodesic is simply the shortest possible path between 2 points within a specific geometry. In flat space, a geodesic is just a straight line.
Makes sense.
But on the curved surface of the Earth, for example, a geodesic is a great circle, like the flight path of an airplane over the pole.
Right. It looks curved on a flat map, but it's actually the straightest path.
Exactly. The Quizzical model mathematically redefines the space-time immediately surrounding the confined photon. The energy of the field itself modifies the local topology such that the continuous double loop becomes the geodesic.
Oh, wow.
The light is traveling in what it perceives to be a perfectly straight line through its own locally curved geometric space.
But to make a topological donut mathematically rigorous without breaking the foundational laws of physics, Dr. Williamson had to go back to the absolute drawing board. He couldn't just, staple a donut onto quantum mechanics.
No, that wouldn't hold up.
He had to rewrite the underlying rules of Maxwell's equations, which govern classical electromagnetism, and synthesize them with Dirac's equations, which govern the relativistic quantum mechanics of the electron.
It's a monumental task.
Yeah, and he details this massive ground-up rebuild in his 2015 paper using a profoundly different philosophical approach to mathematics.
Because the current trend in high-energy physics is to rely on vastly complex, assumed mathematical structures. String theory, for example.
Right, string theory.
It demands 11 spatial dimensions just to make its equations balance. Other models assume complex, multidimensional symmetry groups right out of the gate.
Just making things up to fit the math?
Essentially, yes. But Dr. Williamson rejects these a priori complexities.
Yeah.
He argues that we shouldn't be adding hidden dimensions to force the math to work. We should be finding the fundamental geometry of the dimensions we already observe.
Which is so much cleaner.
He aims for the simplest, most primitive algebra possible, deeply rooted in Clifford algebra and geometric spacetime algebra.
So he strips reality down to just 4 unit vector directions. 1 temporal direction, which is time, and 3 spatial directions, which map perfectly to our physical experience of length, width, and depth.
Just the 4 basic dimensions of Minkowski spacetime.
Right, and from just those 4 fundamental directions, applying strict mathematical rules of geometric multiplication, the algebra naturally generates exactly 16 linearly independent spacetime forms.
If you look at the binomial expansion of 4 elements, you get 1, 4, 6, 4, and 1. Those map directly to real geometric realities.
Let's trace how a toddler playing with building blocks would construct those 16 elements, because I think it maps perfectly and helps visualize it.
I love this analogy.
The 1 is a zero-dimensional scalar, just a single point.
Right.
The 4 represents the 4 one-dimensional vectors, so 4 independent lines you can draw in space and time. The 6 represents the 6 possible two-dimensional bivectors, which are flat planes constructed by multiplying 2 lines together.
Like building a square.
Exactly. Then the next 4 represents the 4 possible three-dimensional trivectors, or solid volumes, like a block. And the final one is the 4-dimensional pseudoscalar, representing the entire spacetime volume. So 1 plus 4 plus 6 plus 4 plus 1 equals exactly 16 geometric forms.
And this is exactly where Dr. Williamson introduces his defining concept, the VOT.
VOT.
Yes. VOT stands for square root mass energy density. It is the fundamental raw currency of reality before it takes on observable properties.
The raw currency.
The theory posits that the entire universe consists of this singular root energy flowing between those 16 simple geometric forms. And depending entirely on which geometric shape the VOT occupies, it manifests to our instruments as different physical forces.
Okay, the mapping of these VOTs to observable physics is where the theory actually builds the electron. Let's look at the specific forms.
Let's do it.
If the root energy, the VOT, exists purely as that zero-dimensional point, the scalar value, it is defined as p-VOT. In our physical world, a stationary point of energy density manifests as rest mass density. So p-VOT is the absolute core of what we perceive as a mass.
Right. And moving up a dimension, if the energy flows into the one-dimensional line, the 4 vector, it becomes v-VOT.
V4 vector.
Yes, energy moving along a line is a current, so v-VOT manifests as current density. When the energy occupies the two-dimensional plane, the bivector, it becomes suffot, or bvot.
Okay, planes.
This is critical because classical electromagnetism requires a plane to define fields and curl. Therefore, the fevot physically manifests as the electromagnetic field itself.
Then we get to the three-dimensional volumes, the trivectors, which is the 2-VOT. If energy occupies a rotating 3D volume, it manifests as angular momentum or quantum spin.
Yeah.
And finally, the 4-dimensional volume, the q-VOT, which governs the divergence of these energies across space and time. So Dr. Williamson hasn't invented new forces at all. He has taken the existing forces mass, current, electromagnetism, and spin, and proved they are just the exact same root energy poured into points, lines, planes, and volumes.
Which fundamentally breaks this standard assumption of particle physics.
Right.
Because in the standard model, charge is treated as an axiomatic property.
Right. It's just assumed to be there.
You have an electron, and it just has a negative charge. In this 16-element geometric framework, you do not add charge to a particle from the outside. You do not add mass. Space and time themselves transform geometrically, and the charge is an emergent consequence of the field being confined into a specific shape.
Let's explore exactly how a shape creates a charge. Because the transition from abstract mathematical planes and volumes into a measurable electrical charge is honestly the most compelling part of this theory for me.
It's very elegant.
In the standard model, The point particle just magically radiates a negative field. But in the Quizzical model, charge is an actual mechanical process.
To see the mechanism, we have to return to our topological donut. A freely traveling photon has an oscillating electric field.
Moving through space?
The vector points up, then down, then up, then down as it propagates. The net charge over time is zero. It cancels itself out.
Right.
But when you bend that specific Compton wavelength into the double-covering toroid, the geometry completely alters the orientation of those vectors.
Because the length of the loop perfectly matches the wavelength of the oscillation, the field gets rectified.
Rectified, yes.
As the wave cycles to its up phase, it is on the outside of the donut. As it cycles to its down phase, it is on the inside of the donut.
Which is exactly the necessary mechanism. Because of the specific twist in the Möbius-like double loop, all the outward-pointing field vectors cancel out, and the geometry forces the net electric field to point continuously and permanently in one singular direction relative to the center of the toroid.
Always pointing one way.
Depending on the chiral orientation of the initial twist, whether it twisted left or right, the rectified electric field points continuously inward toward the center, or continuously outward away from it.
So, if the geometry forces the field to point continuously inward, it interacts with the surrounding space exactly like a negative point charge.
Which we call an electron.
If the twist is reversed and the field points continuously outward, it interacts exactly like a positive point charge. We call that a positron, the antimatter equivalent of the electron.
It's a perfect mirror.
Charge is not a magical fluid the particle holds. Charge is literally just the topological orientation of trapped energy. And the Quizzical researchers don't just propose this conceptually, they actually derive the numerical value of the electron's charge purely from this geometry.
Yeah, the mathematical derivation is startling. They take this toroidal volume and make a single thermodynamically logical assumption.
Which is what?
That the confined energy density is distributed equally between the electric field and the magnetic field. By integrating the field vectors over the specific topology of the double loop, the geometry calculates the effective charge to be 1.47 times 10 to the negative 19th coulombs.
The real experimentally measured value of the fundamental charge of an electron is roughly 1.6 times 10 to the negative 19th coulombs.
That's incredibly close.
Using nothing but geometric vectors and the assumption of equal energy partition, this topological model gets within 9% of the real experimental value of the universe.
And they didn't cheat.
They didn't plug 1.6 into the equation to balance it out. The number emerged naturally from the shape of the knot. So I ask you, the listener, what stands out to you? Because for me, it's that charge isn't a thing. It's just a shape.
An emergent property derived from topology is exponentially more robust than a parameter that must be manually measured and injected into an equation. And this geometric derivation doesn't stop at charge. It provides a purely mechanical explanation for quantum spin, solving one of the most frustrating visualization problems in modern physics regarding fermions and bosons.
The spin transition is a huge hurdle for anyone studying quantum mechanics. Let's break down the definitions first so we're all on the same page.
Yeah, good idea.
An incoming, freely traveling photon is classified as a boson. Bosons possess integer spin, so spin values of 1, 2, and so on. Geometrically, integer spin means if you rotate the particle 360 degrees, one full circle, its quantum state looks exactly the same. It is symmetrically straightforward.
But an electron is not a boson. It is a fermion.
Right.
Fermions possess half-integer spin, specifically spin 1/2. Fermions have a deeply counterintuitive mathematical property. If you rotate a fermion 360 degrees, its quantum wave function is actually inverted.
It's upside down.
It does not return to its starting state. You physically have to rotate the fermion a full 720 degrees, 2 complete circles, before it returns to its original configuration.
Which makes zero intuitive sense if you view the electron as a tiny billiard ball. How can you turn a ball in a complete circle and have it not be facing the same direction?
You can't.
It requires abstract multidimensional math to justify in the standard model. But how does the Quizzical model solve this with just 3D geometry?
It solves it perfectly through the path of the geodesic on the torus. Remember, the photon, the integer spin boson, is tracing a geodesic that loops twice around the inside of the donut for every one time it circulates the main outer ring.
The double loop.
The path is a double covering loop.
So if you trace a single point of energy along that path and you track it for 360 degrees of rotation around the main axis, it has only completed half of its internal journey. It is on the opposite side of the internal cross-section.
That is the physical mechanism of half-integer spin.
Wow.
Because of the double looping topology, you physically must follow the energy through two complete 360-degree rotations, 720 degrees total, for the internal phase of the wave to return to its exact starting orientation.
It's just longer track.
The 720-degree symmetry isn't some abstract mathematical rule. It is the literal, physical distance required to traverse a double-twisted track. The geometry of the knot physically transforms the photon into a fermion.
The physical reality of the double looping path perfectly answers the abstract mystery of spin. That is so satisfying.
It really is.
But building this robust physical structure brings us to a massive contradiction. If the electron is actually a toroid of light, and its diameter is determined by its Compton wavelength, we are talking about an object roughly 10 to the negative 12th meters across.
Small, but measurable.
That is small, but it's substantially larger than a zero-dimensional point. So why do CERN's multi-billion-dollar particle colliders, which can probe distances vastly smaller than 10 to the negative 12 meters, still see the electron as a perfectly structureless point?
That is a big pushback.
Right, when they smash electrons together at 99.999% the speed of light, they find absolutely no evidence of a donut. Why does the internal structure remain invisible to us?
To explain that invisibility, the quizzical researchers lean heavily on Louis de Broglie and his relativistic concept of the harmony of phases.
De Broglie, okay.
De Broglie realized that when an object with an internal frequency moves through space, the laws of special relativity severely distort how that internal frequency interacts with the outside world.
Let's visualize the mechanics of this internal distortion. We have the confined photon racing around the donut track at the speed of light, c.
Right.
This continuous circulation acts like an internal clock ticking away at a steady frequency. Now, we place that entire electron into a particle accelerator and accelerate the whole donut forward at a velocity, let's call it v, which is close to the speed of light.
Because the electron is now moving through space at velocity v, the light circulating inside it experiences profound relativistic Doppler shifts.
Just like a siren changing pitch as a fire truck drives past.
Exactly like that. The portion of the internal light loop that is currently sweeping forward in the same direction the electron is traveling has a relative velocity that combines with the forward motion. To an outside observer, that light is heavily blue-shifted.
Its wavelengths get squished.
Yes, its wavelength is compressed and its frequency spikes.
Conversely, the portion of the light loop that is currently sweeping backward against the direction of the electron's travel is redshifted. Its wavelength is stretched out and its frequency drops.
Yep.
So, occupying the exact same tiny volume of space, you simultaneously have a very high blue-shifted frequency and a very low red-shifted frequency.
And when two different wave frequencies occupy the exact same space, they interfere with one another. They generate what is called a beat frequency, an envelope wave that pulses over top of the underlying waves.
Like tuning a guitar and hearing that wobbling sound.
Perfect analogy. The mathematics of combining that specific blue shift and red shift creates a spatial interference pattern. That resulting interference pattern is exactly the de Broglie wavelength.
The fundamental wave nature of matter that we measure in high-energy experiments.
Exactly. And as the velocity v increases, the difference between the blue shift and the red shift becomes more extreme. The interference pulses get closer and closer together, meaning the de Broglie wavelength gets shorter and shorter.
And if you are a physicist at CERN, you use high-energy, fast-moving electrons as your probes to smash into other electrons, hoping a shorter wavelength gives you higher resolution.
But the quizzical authors demonstrate mathematically that this is a self-defeating process.
How so?
The resolving power of any particle interaction is intrinsically linked to half of its de Broglie wavelengths. But as you accelerate the electron to get a shorter wavelength, the relativistic Doppler shifts within the toroid cause the apparent spatial dimension of the electron itself to contract.
Because of relativity.
Yes. The crucial finding in their math is that the physical dimension of the electron contracts faster than the resolving power of the probe improves.
So it's like trying to take a crystal clear photo of a race car with a camera that is also vibrating. The harder you look, the blurrier the camera gets. The point particle is an illusion generated by relativity.
Precision, yes.
It is not that the electron is actually a zero-dimensional dot. It's that the relativistic physics of trying to measure a moving internal clock forces the interaction to behave exactly as if it were a zero-dimensional dot.
It hides itself.
The internal structure is masked by its own Doppler interference.
It creates an ultimate impenetrable cosmic veil. The toroidal structure is there, governing the mass and charge, but special relativity physically prevents us from mapping its geometry using brute force high-energy collisions.
Okay, so we have mapped the geometry, we derived the charge, explained the spin, and justified why it looks like a point, but we still haven't addressed the most fundamental structural question.
The confinement.
What is the actual mechanism of confinement? What keeps this energy trapped in a continuous loop? If it's not gravity, and the vacuum is just empty space, why doesn't the topological knot simply unspool and release the photon to fly away?
The mechanism of confinement requires looking at nonlinear electromagnetic phenomena, specifically focusing on an extreme threshold known as the Schwinger limit.
The Schwinger limit.
The Schwinger limit describes an electric field intensity of roughly 1.3 times 10 to the 18th volts per meter. It is a level of voltage so incomprehensibly high that it fundamentally alters the nature of empty space itself.
Let's break down why empty space cares about voltage. Because in quantum field theory, the vacuum of space is not truly empty.
Not at all.
It is a boiling sea of quantum fluctuations. It's teeming with virtual electron-positron pairs that continuously pop into existence, annihilate each other, and vanish back into the vacuum almost instantly.
When an electric field reaches the Schwinger limit, it becomes strong enough to physically rip those virtual electron-positron pairs apart before they have a chance to annihilate.
It tears them away from each other.
The field injects enough energy into the vacuum to convert virtual particles into real, permanent matter and antimatter. The vacuum itself becomes polarized. It transitions from an empty void into a highly conductive medium.
But if we look at the calculated electric field inside the electron's toroid, the average field density doesn't quite reach 1.3 times 10 to the 18th volts per meter.
The average field does not, no.
Mm-hmm.
But the researchers theorize that during the initial formation of the knot, perhaps in the chaotic high-energy environment of particle pair production, the localized field intensity, the twisting photon, momentarily spikes and brushes against that Schwinger limit.
Just for a fraction of a second.
When it does, the vacuum immediately surrounding the photon polarizes.
It creates a boundary layer. The extreme localized field alters the refractive index of the vacuum space around it, essentially creating a mirrored wall made of polarized spacetime.
A topological seal.
The photon becomes trapped inside a self-closed magnetic continuity. It's as if the sheer intensity of the twisting energy causes space-time to scar over and heal itself around the knot, permanently sealing the photon in this new topological state.
And once that topological knot is sealed, it is locked by the fundamental laws of conservation. Because the specific geometry of the twist creates a net charge, and the conservation of charge is an absolute law of the universe, the toroid physically cannot spontaneously unspool back into a neutral photon.
It's stuck.
The knot is mathematically and physically permanent until it encounters an antimatter particle with the exact opposite topological twist, at which point they annihilate. The knot unwinds and the trapped light is released back into the universe.
The confinement is maintained by the breakdown of the vacuum itself. I mean, this framework is staggeringly elegant. It resolves the infinite energy paradox, explains the origin of mass and charge mechanically, and integrates quantum spin perfectly with spatial geometry.
It checks a lot of boxes.
Which immediately begs the question, if this mathematical model is so robust, why isn't this being taught in every university? Why are we still spending billions building larger point particle colliders if the point particle is a known relativistic illusion?
This introduces a significant sociological component to the quizzical materials. In the video presentations, Dr. Williamson speaks candidly about his experiences within the mainstream physics establishment, specifically his time at CERN.
Right.
He claims that massive institutions are intrinsically resistant to models of extreme simplicity because it threatens their operational model.
Okay, we need to be explicitly clear with you, the listener here. We are impartially reporting Dr. Williamson's views as presented in the source material. We are not taking sides, nor are we endorsing the claim that CERN is intentionally suppressing geometric physics to protect its funding. We are simply examining the institutional dynamics as described by the authors of this theory.
Acknowledged. And Dr. Williamson's argument is that the current paradigm of big science relies heavily on continuous expansion. The standard model of particle physics requires dozens of arbitrary parameters, particle masses, and coupling constants to be manually measured and plugged in.
It requires a lot of manual tuning.
Exactly. To find these parameters, institutions must build ever larger, ever more expensive machines to smash particles at higher energies. He argues that if a theory of everything were accepted, one that derives all particles and forces from just space, time, and confined energy using geometric algebra, it would effectively eliminate the need for multi-billion-pound collider projects.
He's applying the concept of institutional inertia to physics. The assertion is that an establishment built on discovering hundreds of complex, fragmented particles will structurally reject a unified theory that reduces reality to a single twisting photon.
Because accepting the simple truth would shut down the complex machine. It is a tension that has existed throughout the history of science, really. The struggle between lone theorists seeking fundamental, elegant simplicity and massive, entrenched experimental institutions that operate through brute force, high-energy discovery.
It's an old story.
The Standard Model is messy and mathematically frustrating, but it has decades of institutional momentum. Shifting to a quizzical model wouldn't just require rewriting textbooks. It would require dismantling the entire socioeconomic structure of high-energy physics research.
But regardless of the sociological battles, for any physical theory to graduate from beautiful philosophy to actual science, it must make unique, testable predictions.
It has to be provable.
It cannot just explain what we already know in a new way. It has to predict something we haven't seen yet and give us a way to find it. How do the quizzical researchers propose we prove the existence of this underlying Vought framework?
The 2015 paper outlines several truly radical experimental proposals. Let's return to the concept of PVOD.
The mass density.
Yes, the specific geometric form of root energy that manifests purely as scalar rest mass density. In an electron, that PVOD is integrated with the electromagnetic FVOD in the spinning TVOD. But the paper mathematically demonstrates that free PVOD could exist naturally in the universe.
Wait, free PVOD? Free PVOD would be pure, unknotted mass. It would have no electromagnetic field, meaning it would not interact with light at all.
It would emit light, absorb light, or reflect light.
But because it has mass density, it would interact gravitationally with other mass.
A form of matter that is entirely invisible to electromagnetic sensors but exerts a gravitational pull on galaxies. The paper explicitly identifies free PVOD as a fundamental candidate for dark matter.
Wow.
They are predicting that dark matter isn't some exotic, undiscovered, weakly interacting massive particle. It is simply the raw, geometric root energy of space-time manifesting as mass without an accompanying electromagnetic structure.
That is huge. And the paper goes a step further than just observing galaxies, doesn't it? They propose an experimental mechanism to physically generate free PVOD in a laboratory.
They do.
The hypothesis relies on the strict conservation of energy. If you set up an experiment in a perfect vacuum and you take incredibly intense electromagnetic fields and perfectly cancel them out through destructive interference, well, the energy of those fields cannot simply vanish.
The energy must be conserved. If the electromagnetic FVOD geometry is forced to zero through interference, the equations dictate that the energy must condense into a different geometric form. The paper theorizes it would condense directly into PVOD.
Let's trace the physical consequence of that. Because if you cancel out intense light in a vacuum, you generate a localized density of pure, invisible mass. And because it is mass, it is subject to gravity.
It falls.
The paper literally suggests that you could measure this by watching the newly formed PVOD fall in a gravitational field, perhaps detecting its impact on a highly sensitive, wall-mounted light table or a gravimeter beneath the vacuum chamber.
It's hard to believe.
They are predicting that we can create literal falling drops of dark matter by extinguishing light.
It is a profound, paradigm-breaking prediction. Furthermore, they suggest that while the de Broglie wavelength blurs brute force high-energy collisions, we might be able to detect the toroidal structure using lower energy, highly specific probes.
How would that work?
They propose polarized electron scattering experiments conducted within extremely strong magnetic fields. The magnetic field could orient the toroids, and by measuring the precise scattering angles of incoming polarized photons, we might finally pierce the relativistic veil and detect the asymmetric, non-point-like nature of the electron.
If those scattering experiments succeed, or if a vacuum chamber suddenly starts raining invisible mass, the foundations of modern physics will have to be entirely rebuilt.
From the ground up.
We started this deep dive staring at the infinite energy paradox of a zero-dimensional coordinate. We unpacked the topological mechanics to see how a simple twisting wave of light can bend into a double-looping donut, converting linear travel into inertial mass.
The quantum bicycle.
We explored a 16-element geometric algebra, where charge is a physical process of rectified energy. We discovered how relativistic Doppler shifts create the illusion of a structureless point. And we ended with a roadmap to generating pure mass from canceled light.
If you carry the logic of this theory to its ultimate conclusion, it offers a breathtaking vision of the future.
What do you see?
Well, if the rigid, unyielding mass of the electron is nothing more than a specific topological knot tied in the fabric of electromagnetic energy, what happens when our technology advances to the point where we can tie entirely new knots?
Oh, wow.
If we can manipulate the local geometry of space-time, future physicists won't just be limited to discovering the particles that nature already created. They might be able to artificially weave entirely new, custom-designed subatomic elements out of pure light, engineering matter from the quantum geometry up.
And with that vision of weaving light into new realities, we are going to wrap up. Thank you for joining us on this deep dive. Keep looking at your hands, keep wondering about the hidden geometry of the solid world, and never stop questioning the universe.